All right, so I just wanted to make a video. I've had a lot of email questions about Hardy Weinberg, and I want to try and go over it a little bit different way. In class, we're going to go through this PowerPoint as well, so I just want to make sure that everybody's getting the same help for our test. Okay, so why do we use Hardy Weinberg? Hardy Weinberg is basically saying that we need to find a way to count the genes in a population. So we're really, our goal is to find out the chance that we're going to inherit one gene versus another. Okay, so Hardy and Weinberg established this equation to help us kind of guess the probability of either being dominant or recessive. Okay, and they did this really by setting up these two different equations, p plus q equals 1, and p squared plus 2pq plus q squared equals 1. Okay, so all of these things are just saying the dominant alleles plus the recessive alleles equals the number, the total population, 1, or the number of homozygous dominant plus the heterozygous plus the homozygous recessive equals 1. So the number of either genotypes or phenotypes is equal to 1, that one population. All right, so what do all of these letters or variables mean? Okay, so in class, everybody gets a whiteboard, and then I'll write this, or I put this slide up, and then I say, write down what P equals in 30 seconds, and then they write down what P equals, and then we pass out prizes, and that's kind of our game review for this week. Okay, so what I want you to do, just take a second right now. I'm going to pause the video on my end, and I'm going to write down P equals Q equals P squared equals 2PQ and Q squared equals. So go ahead and write now and answer those questions. All right, so now hopefully I gave you enough time, or hopefully you paused it enough. P is equal to our dominant allele. So anytime we see the word just allele, and if it gives us the dominant, we're going to use the letter P. If it gives us the recessive allele and only the allele, we'll use the letter Q. If it tells us the homozygous dominant, that is P squared. If it tells us the heterozygous, that is 2PQ. And if it gives us the homozygous recessive, that is Q squared. Okay, so you're going to want to use that information. So I would write that down on a piece of paper, save that. That's going to become important. For your test, you're allowed to use a blank piece of paper because we're doing calculations. So if the first thing you do when you get the test, once you open it up, if you want to write these things down, you can. Feel free to use that, okay? All right, so this is also answered on the next slide. So hopefully you've checked that. You can see that we have the same answers that you just put on your piece of paper on your whiteboard. Okay? All right, so how do we use these variables? How did Hardy and Weinberg set up this equation to allow us to use it? Okay, so basically what we can do is we can look at a population. The only way for a homozygous recessive or a recessive trait to be shown in a population is if it's homozygous, okay? And that was covered in that lab that you guys did with the pink pigs versus the black pigs. The recessive trait can only be expressed if both alleles are recessive. And we're going to go more into that in our genetics unit next semester, okay? But with Hardy and Weinberg, if we can find Q, we can find anything else from that point. But we have to know what we're solving for to start. All right, so practice problem number 1. So I'm going to write down my given information. Okay, in a population of frogs, brown skin is the recessive phenotype. So I'm going to write down brown equals recessive. Okay, in a population of 10 frogs, 4 of 10 are brown skin. The other 6 have green skin. What do I know? Okay, so right now I've given down, this is what I know. I know that brown is recessive. I know that 4 out of 10 have my brown skin, and 6 out of 10 have green skin. Okay, so what can I do with that information? Remember, anytime they give me the phenotype or genotype, that's telling me Q squared or P squared. Okay, so in this case, they give me Q squared is 4 out of 10. Okay, I know that because Q squared is my homozygous recessive, and the only way to have brown skin would be little g. So that's my homozygous recessive. So Q squared equals 4 out of 10. All right, so how do I solve for q, right? What am I solving for? Every time I need to find q first. Okay, so what I'm going to do, anytime I've got something squared, I can just square root it. Okay, so q squared, the square root of that. Okay, and if I think about that, I can't really square root a fraction. Okay, so I'm gonna have to take my fraction 4/10 and change that into a decimal. So q is going to be the square root of 0.4. Q equals the square root of 0.4. Okay, so I got my calculator ready. I'm going to put q, or the square root of 0.4, and that tells me 0.632. 0.632. Okay, for my class, I do not care about significant figures. I just round to the 100th position, which is the second decimal point. So 0.632 is equal to 0.63, or 63% of the population have the brown allele. Okay, so there's my 0.63, there's my 63%. Okay, all right, so practice problem number 2. This one's about sickle cell anemia. I'm going to go ahead and erase my whiteboard while I'm working on this. All right, sickle cell anemia is a recessive disorder known as little s, typically found in Latino and African American populations. It is estimated that 15 out of 1,000 Americans have sickle cell anemia. 15 out of every 1,000. So I'm going to write that down. That's good. That's what do I know? Okay. What is the percentage of Americans that do not have sickle cell anemia? Okay, so we're going to come back to that. Right now, I know that 15 out of 1,000 are my little s. Okay, little s is saying the same thing as homozygous recessive. So I'm going to put q squared is equal to, I'm going to use my calculator, 15 divided by 1,000, and change that fraction into a decimal. We can work with decimals better than we can with fractions. All right, so 15 divided by 1,000 is equal to 0.015. Okay, so q squared is equal to 0.015. All right, so I know q squared. Always find q next. Okay, so if I know q squared, if I square root both sides, okay, so that means that q is equal to the square root of 0.015. Q is equal to the square root of 0.015. If I plug that into my calculator, Q is equal to 0.12. Q equals 0.12. But we're not done, okay? What it asks me to solve for from there, always find Q first. What is the percentage of Americans that do not have sickle cell anemia at all, that are big S, big S? Okay, so big S is the same thing as saying homozygous dominant, or p squared. Okay, so this problem is asking me to solve for p squared, but I only know q. So how can I jump from q to p squared? Okay, remember that one equation we had where p plus q equals 1? All right, if I know q, I can easily solve for p. So p is going to be equal to 1 minus 0.12. So p is equal to 0.88. Okay, so p equals 0.88. Okay, now I can solve it. I'm looking for p squared, not p. So p squared is the same thing as saying 0.88 squared. All right, 0.88 squared. I'm going to plug that into my calculator, and that is going to be my answer, 0.88 squared. Okay, I got 77%, or 0.77. Okay, so p squared equals 0.77. Or 77%. Okay, so p squared, remember I just solved p times p to get that answer. All right, practice problem number 3. Sickle cell anemia is a recessive disorder typically found in Latino and African American populations. It is estimated that 15 out of 1,000 Americans have sickle cell anemia. Okay, so 15 out of 1,000 is equal to our Q squared. So first thing I need to know, what is Q? So I'm going to take the square root of both sides. So then Q is equal to 0.12. Okay, if this problem sounds really familiar, it's because it's the same setup as the last one. Okay, the only difference is, what am I solving for? All right, last time we were solving for the homozygous dominant. This time we're solving for the heterozygous. Okay, so big S, little s, also known as 2pq. All right, so I know 2, that's just a number, and I know q, that's just a number. So now I need to solve for p. All right, so p is equal to 1 minus q. Sorry about the lights. So p equals 1 minus q, so p is equal to 0.88. All right, now I'm going to plug that number into my equation. 2 times p times q. 2 times p times q. So I'm going to go ahead and plug that into my calculator. 2 times 0.88 times 0.12 is equal to 0.2112. Or 21%. Okay, so I just plugged my numbers in, 2 times 0.88 times 0.12, and that gives me my 21% or my 0.21 if I leave it in decimal form. Okay? All right, practice problem number 4. Color blindness is a recessive disorder. In a population of 500 people, it is estimated that 50 of them will have the colorblind allele. So 50 out of 500 is equal to what? Okay, in this case, they tell us specifically the colorblind allele. If I look at my notes from P and Q, remember that Q is equal to my recessive allele. So in this case, I don't have to solve for Q. They already gave it to me. 50 divided by 500 is equal to my Q. So I'm going to go ahead and turn that into a decimal real quick. 50 divided by 500 is equal to 0.1. All right, so Q is equal to 0.1. All right, what do I know? So I know Q, that's what we just wrote down. What am I solving for? Okay, in this case, it says what percentage of the population are carriers and do not show symptoms. So right there, it shows big C, little c. So they're asking me to solve for the heterozygous. Okay, so the heterozygous, remember we just did a problem like this for the last set, is 2pq. All right, I know q is equal to 0.1, but I don't know p, so p is equal to 1 minus 0.1, so then p equals 0.99. All right, so now I've got p, I've got q, now all I have to do is plug them into my equation. 2 times 0.99 times 0.1 is going to give me the answer, or the percentage of people that have color blindness, but they don't know that they have color blindness. They are just carriers for the disorder. Okay, so I got 0.198, or we can go ahead and round that up to 0.20, or in other words, 20% of the population. 20% of our population has the color blindness allele, but they are not colorblind. Okay, in this example, 20% will be your final answer. Okay. All right, practice problem number 5. Feel free to pause this video as I'm going through these and solve them on your own. But I just want to make sure that you've got the right answers as well. Okay, so practice problem number 5. It's set up very similarly to number 4, but asks us for a different answer. Okay, so I'm going to write down Q is equal to 0.1. The only reason I can write that down is because I already wrote it down in problem number 4. Okay, if you don't remember how we got that, we just divided 50 by 500, and that gave me the 0.1. Okay, remember anytime they give me the allele, that's telling me Q versus the phenotype or genotype is telling me the Q squared. All right, what am I solving for? In this case, they're asking me to solve for big C, big C. If I look back at my vocab words, big C is the same thing as saying my homozygous dominant. So in this case, I'm solving for my homozygous dominant, and my homozygous dominant, my variable for that, is P squared. Okay, so I don't know P yet, or if you paid attention in the last question, we solved for P. P was equal to 0.99. Okay, so 0.90. All right, so what I'm going to do is I'm going to take P squared to find P squared. So I'm going to take 0.9 times 0.9, and that should give me my answer. Okay, 0.9 times 0.9 is 0.81, or 81% of the population. Okay, 81% of the population are not colorblind at all. They do not have that allele. All right, what I want you to do, and this is what we're doing in class, these problems are, if you want to call them homework, if you want to call them review for the test, solve these on your own. Okay, these questions, I went ahead and put the solutions on the PowerPoint as well. So pause the video, answer the questions, check your answers with the video. All right, as always, if you have questions, email me, but here's the answer to question number 1, here's problem number 2, and the answer to problem number 2. Okay, so don't feel like just because you don't solve it first right doesn't mean that you don't know what you're doing. Use the answer keys to check, use this video, and if you have any questions, shoot me an email.